In this video you will learn about history of GPS, how GPS works in aircraft, GPS components, GPS errors, frequency band on which it works and principle of operation. So let's roll and get started. First of all, let me tell you that GPS topic is basically a part of DGCA navigation exam subject, which is frequently asked by DGCA in navigation exam in each attempt. So let's start with history of GPS. GPS is a space-based radio navigation system owned by the United States government and operated by the United States Air Force. The United States military first used GPS as a navigation tool in the 1970s. In the 1980s, the U.S. government made GPS available to the general public, free of charge. GPS system provides geolocation and time information to a GPS receiver anywhere on or near the Earth. GPS components. The GPS system has three main components. 1. Space segment. The space component consists of about 31 GPS satellites. The United States Air Force operates these 31 satellites, plus 3 to 4 decommissioned satellites that can be reactivated if needed. A minimum of 24 satellites are operational at any given moment, ensuring that at least 4 satellites are in view at the same time from almost any point on Earth. In a specially designed 6 orbits at around 10,900 nautical miles, which is around 20,200 kilometers above the Earth, taking about 12 hours for each orbit. The orbits are inclined at 55 degrees to the Earth's equatorial axis. Each satellite carries 4 atomic clocks, which are compared internally with each other, to provide average time high accuracy. Accuracy is of the order of nanoseconds. The complete coverage that satellites offer makes the GPS system the most reliable navigation system in modern aviation. 2. Control segment. The control segment is made up of a series of ground stations. It consists of worldwide monitor and control stations that is used to interpret and relay satellite signals to various receivers. Ground stations include a master control station, an alternate master control station, 12 ground antennas and 16 monitoring stations. In simple language, control stations look after GPS satellites, to maintain satellites in their proper orbits. It also adjusts satellite clock and uploads updated navigational data. 3. User segment. The user segment of the GPS system involves various receivers from all different types of industries. National security, agriculture, space, surveying, and mapping are all examples of end users in the GPS system. In aviation, the user is typically the pilot, who views GPS data on display in the cockpit of the aircraft. Frequency used. The GPS satellites transmits on 2 different frequencies and the transmission is done on UHF band. First one is called the L1 band, which is transmitted 81.517.42 MHz, which is called as Course Acquisition ORCA code. This provides standard positioning service ORSPS which can be used by all users. Second one is called L2 band, which is transmitted 81.227.6 MHz, which is called as P code or precise code. This provides precise positioning service or PPS, which can only be used by military users only. How it works. Now let's take the closer look how a GPS system works. GPS satellites are solar powered, and fly in medium Earth orbit, and transmit radio signals to receivers on the ground. As I told you earlier that a minimum of 24 satellites are operational at any given moment. These satellites transmits the data, which is called as almanac data. That is basically the specific satellite info to the user. That is their position in the orbit, time and PRN code, that is pseudo-random noise code, which is basically the identification code for each satellite, which allows any user to know which satellite is transmitting. The GPS receiver in an aircraft receives time data from the satellite's atomic clocks. It compares the time it takes for the signal to go from the satellite to the receiver, and multiplies this time with speed of radio wave and to get a range position line. So by timing the signal from 3 satellites will determine a precise 2D or two-dimensional location. And timing the signal from at least 4 satellites will determine a precise 3D or three-dimensional location, which provides user with 3D fix, which gives latitude, longitude, altitude and time information. GPS errors. Everything is perfect in this world, but because we see things up close we are seeing what we believe is imperfection. Similarly, GPS has also got the following 7 errors. 1. Clock time bias error. The clock on a GPS receiver might not be as accurate as the atomic clock on a GPS satellite, creating a very slight accuracy problem. 2. Satellite clock error. Errors in the atomic clock of the satellite, which gives inaccuracies up to 1.5 minutes. 3. Satellite ephemeris error. Satellite may not be where it is saying it is due to disturbance from the planned orbit, due to which orbit calculations can be inaccurate, causing ambiguity in determining the satellite's exact location. 4. Selective availability. The error deliberately introduced by the U.S. to protect its own interest by dithering atomic clocks. 5. Ionospheric refraction. The signal from the satellites actually slows down as it passes through the Earth's atmosphere. It causes the waves to bend a little bit. It is also called ionospheric group delay. GPS technology accounts for this error by taking an average time, which means the error still exists but is limited. 6. Interference. It is due to interference caused from signals on similar frequency, as the frequency received by receiver from the satellite is very weak. It is caused due to distance between the satellite and the receiver. 7. Geometric dilution of position. Between satellites giving position is around 60 degrees. But when the satellites give a poor cut at a very large angle, there is a dilution in the accuracy of the derived position. The best cut is when one is overhead and other 3 are at 120 degrees apart. So that's all for the GPS working. Points to be remembered for DGCA exam. 1. Principle of operation. Timing the signal from satellite to receiver and getting range position line from 4 satellites to calculate 3D fix. 2. To calculate a 3D position in space you need at least 4 satellites giving you range. In case only 3 satellites are available, then only latitude and longitude can be derived and the height can be manually fed. 3. Total 24 satellites are active all the time, which are in 6 orbital planes with 4 satellites in each plane. 4. Each satellite orbit the Earth in 12 hours in an elliptical orbit. 5. Each orbit is inclined at an angle of 55 degrees to the Earth's equatorial axis. 6. Orbit position is called almanac data, which is downloaded in 12.5 minutes. 7. Height of GPS from Earth is around 20,200 kilometers, 10,900 nautical miles. Aircraft position calculated by GPS is over World Geodetic System 1984 or WGS 8-4. 8. Height of Russian GPS, which is also called as GLONASS, is around 19,000 kilometers. 9. Inclination means the angle between satellite orbit and Earth equatorial axis. 10. Best fix is when 1 satellite is overhead and rest 3 satellites are 120 degrees apart. So that's all for GPS working in aircraft. Now you are ready to answer any question comes from GPS topic of DGCA exams. Hope you like the video. Thanks for watching.